Continuing along, some more slicing and dicing. So find the cities that have a higher coli than average. Okay, so first we have to extract df dot coli, okay, dot mean, okay, and then we say df dot coli, okay, greater than df dot coli mean. Okay, so it will go to get a set of booleans. Okay, dot log, and then you pass it down to, and you get that. Okay, so pretty straightforward. We've done that same approach. Okay, so all we are doing is calculating the mean, and you see a set of cities which have higher cost of living index than the mean. Okay, San Francisco is an outstanding citizen here. We know that. New York is coming in. Baltimore, okay, I'm not sure why, because the home prices are pretty reasonable there, so there has to be some other reason why it's higher than the average, but it's not that high compared to this is insane. Still high, not as high. Seattle is pretty compared to all the stuff we are hearing about Seattle, it's pretty reasonable. Okay, Boston, Seattle comparable, and so and so. Okay, find the cities that have higher home price than average. Okay, you know which cities are going to be at the top. Okay, using the same approach. Okay, you see this, so it's pretty you're going to use this over and over again, so it's good to get some practice on it. Okay, so the culprits are the same: Seattle, Solo, San Francisco. Here home price, Salt Lake City is also here. There must be other reasons. Probably the taxes are lower, that's why the cost of living is lower in Salt Lake City, but the home price is still high up there. Okay, not as insane as this, but yes. Standard deviation, yes, you can extract that for a column. The spread in values, you can actually calculate the min and max. What is the spread in value between home price? Okay, that's 625K between the lowest and the highest. Okay, highest is 750K. Okay, which one is the lowest? Okay, let's see which city is the lowest. Okay, so let's say df dot, just doing for the fun of it, home price equals to, okay, so it's going to give you a series of boolean. Okay, so let's see what row is that. Okay, so which is Pittsburgh. Okay, so Pittsburgh has the lowest home value. Actually, yeah. So why would you want to live in? So if you look at the spread in the lower end of what a public teacher or what a public school teacher can make, or what a teacher can make, compared to that and the home price, the ratio. Okay, what's the home price ratio? Okay, that's a good way to sort of calculate. Okay, what is the home price to public school teacher, which is basically HHIL ratio? Okay, where is the highest? So that's an interesting thing to find out. df dot home price divided by df dot HSIL. Okay, so you get a series of values. Okay, so now how do you know which row is what? Okay, you know which one is this. Okay, that has to be that the San Francisco Bay Area kind of ratio. Where is the lowest? So if I am a teacher, I am going to this city. Okay, or at least somewhere in this range. Okay, so let's see what these cities are. So how do we do that? Okay, we can assign it. Are we doing that somewhere later? Oh, we are doing that. Okay, let's delete that. Okay, so let's look at the spread. Okay, what is the ratio of max home price to min? Okay, I don't know what that tells you, but it tells you that from the lowest to the highest you have 6x difference. Okay, which is crazy. Okay, in the same country. Okay, which is expected. You can't have an even distribution of prices everywhere in the country, because some places just happen to have a nicer weather or better quality of life than other places. But yeah, create a column. Okay, so we're going to create a new column. Okay, so now we are going to create a new column called home price by HHIL. So home price divided by HHIL and HHIH. Okay, so this is for teachers and public government workers and so on. So I guess that's how I would quantify them. Okay, or categorize them. And these are basically all the doctors and the engineers and at least the good ones, business owners and all those things, right? So let's look at these two columns. Okay, so we're going to add a new column, two new column to the data, and this is how you will add. Okay, and let's see whether those columns came in. Okay, they did. Okay, and as you can see, this is 11x, okay, of the HHIL, because this is what I worry about, right? As a parent, I want this column to be as reasonable for the teachers who teach in my school or my daughter's school. Okay, I have two daughters, by the way. The teachers who teach in my school can afford to live in the same community as I'm living in, right? So that's something I really want to make sure it happens at some point. Okay, but look at this difference. Okay, the difference is not that much. Okay, but look at the difference in your standard of living if you were to live here versus live here. Of course, it's Arkansas. Oh, Arkansas is not bad. I read about it. Okay, but I've never been there, but I'm sure it's not that bad. But if you look at your quality of life difference between these two places, of course there are other factors in quality of life, but just looking at the cost, okay, that's crazy different. Okay, and that's one of the reasons why I keep reading about it, where teachers are having a hard time living here, and not only teachers, I keep reading about restaurants closing down in the San Francisco Bay Area and so on, so right, because the community which serves us, okay, cannot be around us because of the dramatic differences in the cost of living here versus somewhere else, right? And that's unfortunate. Okay, but it is what it is for now. So create a new column that highlights the distance in dollars from the home price from the minimum value of home price. Okay, so let's so from the minimum value of the home price to each home price, okay, distance in dollars. Okay, so we're going to take the high. So this is another metric you can use to measure so this is like, this could be a measure of your quality of life depending upon how much money you make, right? Home price from min. Okay, you can add another column. Okay, and now you have that home price from minimum. Okay, that another column that highlights the distance in dollars for HHIH from the minimum value of HHIH, okay, which is another column. Okay, so we can keep adding columns like that. Okay, and what I want to do is now drop all the columns I just added. Okay, just to make sure that we go back to the original data set. Okay, so how would I typically do that? So normally when I work with data sets, I add columns just to think out loud as to which ones should I keep, which one do I want to keep. And you will do that more and more often when you actually build models, when you are actually building models on it, on data sets, let's say some kind of a prediction model, right? You will form new columns, out of a combination of other columns and so on, so right? But let's say I want to drop some of these columns, so I can do drop, okay, df.drop, okay, and I provide a list, okay, of all the columns I want to drop. Okay, I definitely don't want to drop city because that's part of the original data set. All these are part of the original data set. Okay, starting from this point is what I created new. Okay, I'm going to drop all of them. So let's see whether that works. df.drop column values. What's going on? Home price not found in access. Okay, oops, sorry, I have to also specify the axis. Okay, axis equals 1, which is I want to drop columns, okay, and not drop row. Okay, so you see you get the original data frame, but I also want to add one more argument, place equals true. Okay, that's really dropping all the columns and bringing the data frame back to the way it was. Okay.